October 19, 2017. The Haleakala Observatory, Hawaii.
The Panoramic Survey Telescope and Rapid Response System, Pan-STARRS-1, is conducting its nightly sweep of the heavens. It is a silent, automated sentinel, its prime directive to map the celestial grid, hunting for anomalies. An algorithm flags a deviation, a single, faint point of light moving too fast on the wrong path. Designation: A/2017 U1. The system primary function is planetary defense, a digital tripwire designed to identify near-Earth objects. Every night, it ingests petabytes of data, comparing the current sky to established star charts, flagging any movement.
A/2017 U1 was initially catalogued as just another data point, likely a small asteroid or a faint comet.
Flung from the distant Oort cloud. Standard procedure was initiated. Track the object, calculate its orbit,
And determine if it posed any conceivable threat to terrestrial assets. It was a routine classification for a target
believed to be native to our own solar system.
But as observatories across the globe trained their sensors on the target, the telemetry data painted an impossible picture.
The orbital parameters were not neatly elliptical, not even the long, stretched-out parabola of a comet, or from the deep freeze of our system's edge. The numbers that returned from the Minor Planet Center were stark, stripped of all ambiguity. The object's trajectory was hyperbolic.
Its orbital eccentricity was 1.2.
This object was not a prisoner of our sun. It was a tourist, a trespasser, moving with enough velocity to escape back into the interstellar void from which it came.
This was designation 1I/2017 U1, the I for Interstellar.
For the first time in history, we had confirmed contact with an object of extrasolar origin.
The anomaly was no longer a simple data point. It was an artifact from another star system. It had already made its closest approach to the Sun a month earlier and was now rapidly accelerating away from us. The clock on this investigation was already ticking, and we were losing time.
The anomaly was identified. The case file was opened.
The central problem was not merely its origin, but its nature. Hindrances. The global astronomical community now faced an unprecedented operational challenge to conduct a complete forensic traveling at over 57,000 meters per second, with only a few precious days of observation remaining, before it faded into the black, forever beyond the reach of our sensors. The hunt for intelligence was on.
With the target escaping at nearly 19 kilometers per second relative to Earth, the window for intelligence gathering was perilously brief.
A coordinated global campaign began, a race against geometry and time. The largest telescopes on the planet,
from the Very Large Telescope in Chile to the Gemini Observatory in Hawaii, swiveled to acquire the faint signal.
The mission was simple: gather every photon, every scrap of telemetry, before the object slipped beyond our grasp.
And its signal was lost to noise. We had to build our entire dossier on the fly.
The first critical piece of intelligence came from its light curve. Photometric data from multiple observatories revealed a radical variation in brightness. It's a change of a factor of 10 or more. The object was tumbling, and as it rotated roughly every 8 hours,
its reflected light signature was fluctuating wildly. This was not the gentle pulse of a spherical or potato-shaped asteroid.
This was the rhythmic flash of a blade spinning in the dark, a sliver of material catching the sun at one angle and disappearing at another. This extreme brightness variation was our first major clue to its physical nature.
To produce such a change, an object must be extraordinarily elongated. The initial models, based purely on this photometric data,
suggested a shape at least 10 times longer than it was wide. We were not tracking a simple rock. The dossier now contained the profile of something akin to a cosmic shard, or a cigar-shaped artifact. This was the first entry in the file that broke all established precedents for asteroids and comets in our system. The next layer of the investigation was composition. The Very Large Telescope conducted spectroscopic analysis, breaking down the faint, reflected sunlight into its constituent colors to search for a chemical fingerprint.
Astronomers were specifically looking for the characteristic signature of a cometary coma, a halo of gas and dust,
sublimating from the object's surface as it was heated by the sun. But the spectrum was featureless. There was no evidence of water, no gas, no dust. The object's surface was dark and reddish,
a color consistent with organic-rich surfaces in our outer solar system, suggesting a composition of rock and possibly metal
that had been heavily irradiated by cosmic rays over an immense, multi-million-year journey. The forensic profile was becoming sharper and stranger. Target is dark, reddish, and inert. Density appears high. Shape is extreme. It spins, but not on its principal axis. It is tumbling chaotically. It displays no cometary activity whatsoever, despite having just passed closer to our Sun than the orbit of Mercury. Every data point confirmed its uniqueness, pushing it further away from any known classification of celestial object.
These findings created significant intelligence gaps, particularly concerning its size. Without knowing its albedo, the reflectivity of its surface,
we could only establish a range of possibilities. If it were highly reflective, like clean ice, its dimensions could be as small
as a few hundred meters in length. If it were as dark as asphalt, which the data suggested, it could be closer to a kilometer.
The consensus settled on a working estimate of around 400 meters, but this remained a critical unknown in the operational picture.
A ghost we were trying to measure with a broken ruler.
Finally, as the object receded, one last avenue of inquiry was pursued.
One of the most sensitive radio observatories on the planet, to perform a forensic search for technology.
For a brief period, we ceased to be astronomers and became signals intelligence analysts, listening. We scanned billions of radio channels across 4 radio bands, searching for any emission, any leakage, any structured signal that would betray an engine, a transmitter, a technological mind.
The result was absolute silence. No signal was detected.
Questions. The intelligence gathering phase was over. The dossier contained the target's trajectory, its extreme dimensions,
The operational picture was established. But instead of solving the anomaly, the data had created a far more profound contradiction.
A central friction point that would define the entire investigation.
The intelligence dossier was now sealed, but the operational picture it presented was deeply fractured. The individual data points were clear, precise, and verified by multiple assets. But when we tried to assemble them into a coherent profile, they refused to fit. The object's trajectory, light curve, and composition were not just unusual, they were contradictory. This operational friction, the growing gap between our observations and our understanding, would come to define the investigation. The most profound conflict, however, was hidden in the very data that led us to the target in the first place: its motion. We now had a baseline of telemetry data tracking the object's precise location over 78 days. Using this, we could build a near-perfect model of its trajectory, accounting for the gravitational influence of the Sun, the Earth, and every major body in the solar system. The expectation was that the object, an inert piece of rock, would follow this path with Newtonian precision. But it did not. After all known gravitational forces were factored out, a tiny but persistent deviation from its predicted course. It was accelerating, very slightly, away from the Sun, with a force that gravity alone could not explain. This was the central paradox of the entire case: a non-gravitational acceleration. The textbook explanation was immediate and obvious: cometary outgassing.
The Sun heats unseen pockets of ice on the object's surface, which then vent into space as gas,
creating a gentle, continuous thrust. This is a known phenomenon, observed in thousands of comets.
For a moment, it was the perfect solution.
But this solution was in direct conflict with our own intelligence.
Our dossier was unambiguous. The spectroscopic analysis from the Very Large Telescope, one of the most powerful instruments on Earth,
showed no signs of gas or dust.
The Spitzer Space Telescope, observing in the infrared, likewise found no evidence of carbon monoxide or carbon dioxide, the typical drivers of outgassing. Furthermore, the acceleration was perfectly smooth.
cometary jets are chaotic, firing from active regions as they rotate into sunlight, causing an object to spin up or tumble erratically.
Yet there was no corresponding change in Oumuamua's rotation period. The dossier was telling us the object was inert, while its trajectory told us it was active. We were now facing a complete operational paradox. The object was moving as if it were a comet, but our forensic analysis of its physical state showed conclusively that it was not a comet.
It was behaving like a car with its engine on, but a detailed inspection showed no engine, no fuel, and no exhaust.
This wasn't just an intelligence gap. It was a direct contradiction in the fundamental evidence.
How does an object generate thrust with no detectable propellant? The friction had pushed the investigation into uncharted territory,
forcing a re-examination of all assumptions.
Alternative natural explanations were proposed, each more exotic than the last. Could it be a nitrogen iceberg chipped from a super Pluto?
Such an object might not show
Such an object might not show up on our sensors, but it would have eroded too quickly. A cosmic dust bunny, a highly porous, low-density agglomerate. It would be too fragile to survive an interstellar journey. A hydrogen iceberg? A theoretical object that has never been observed, and which would have disintegrated long before reaching our system. When all conventional and even exotic natural explanations fail to align with the data, analytical protocol demands that we consider possibilities
that lie outside our existing frameworks. The investigation turned back to the acceleration itself.
The anomalous force was observed to be inversely proportional to the square of the object's distance from the Sun.
This specific mathematical signature is crucial. It meant that whatever was pushing the object, its force diminished in perfect lockstep with the intensity of sunlight. This profile is the unique hallmark of acceleration caused by solar radiation pressure. For solar radiation pressure, the physical push exerted by photons themselves, to be the sole driving force.
The object must possess two extraordinary properties: extremely low mass and a very large surface area relative to that mass.
It would have to be, in essence, a sail. Not necessarily a manufactured one.
Perhaps only a few millimeters thick, allowing it to be pushed by sunlight in a way a dense, rocky object never could. This hypothesis, for the first time, aligned the non-gravitational acceleration with the bizarre, elongated...
We may not have been observing a cigar, but the thin edge of a vast, spinning sheet.
The investigation had reached its breaking point. The friction between the data and theory was absolute. We were left with two irreconcilable profiles: a new, invisible class of comet that violates what we know about physics,
or an object with dimensions and a thickness that suggests something other than a random product of nature. The dossier was no longer a collection of facts. It was a mirror reflecting the profound limits of our own understanding.
So what is the final verdict in the forensic file of 1I/2017 Oumuamua? The target is gone.
It has long since passed the orbit of Neptune, a ghost returning to the void, forever beyond communication or direct observation.
The case, in the strictest sense, remains open. The dossier is filled with high-fidelity data that points in two irreconcilable directions.
And we have no further means of gathering intelligence to resolve the operational friction. It is the perfect, unsolvable mystery.
But the ultimate solution in an investigation of this magnitude is not a final identification of the target.
The solution is the forensic analysis of our own capabilities.
And rapid characterization systems. It revealed a profound intelligence gap. We possess the assets to detect an anomaly, but we lack the ready state and the rapid response interception technology needed to truly analyze it.
We were prepared for threats from within our system, on predictable orbits. We were strategically unprepared for a high-velocity visitor,
on a one-way hyperbolic trajectory.
The long-term impact of this encounter cannot be overstated. The friction generated by this single unsolved
of the next generation of celestial surveillance. The Vera C. Rubin Observatory is designed to find an interstellar object every month.
Mission concepts like the Comet Interceptor are now being built, designed to lie in wait and launch on demand, to rendezvous with a future target. Oumuamua was an alarm, a single, silent flyby that fundamentally recalibrated our entire strategic awareness of the cosmos.
The universe has always sent us messages written in light. This was the first one delivered by hand.
We are still learning how to read the postmark.